So, you've probably used a ton of apps on your phone or computer. Maybe you've played a game, scrolled through social media, or used a calculator. All of that is software, and behind every single piece of software is a team of developers who built it. But here's the thing. They don't just sit down and type out perfect code from memory. They use a whole suite of special tools to help them write, test, and manage their creations. Think of it like this. A carpenter doesn't just use their bare hands to build a chair. They use hammers, saws, and measuring tapes. For software developers, their tools are just as crucial. These tools are what we call software development tools, and they're the unsung heroes of the digital world. They can be as simple as a basic text editor or as complex as an entire platform that manages every step of the creation process. The main goal of these tools has always been the same: to make the developer's job easier, faster, and more efficient. They help catch mistakes before they become big problems. They help teams work together without stepping on each other's toes. And they automate the boring, repetitive tasks so developers can focus on the creative, problem-solving parts of their job. Without these tools, building the software we rely on every day would be incredibly slow and frustrating. Imagine trying to build a skyscraper without cranes or power drills. You could probably do it, but it would take forever and be way more difficult. That's what coding without modern tools would be like. From the very beginning of computing, developers have been creating tools to help them build better software. And the evolution of these tools tells a fascinating story about how technology itself has grown up, becoming more powerful and accessible over the decades. This journey is pretty incredible. It started in an era of giant room-sized computers and has led us to a point where artificial intelligence can help write code for us. Each step along the way introduced a new idea or a new piece of tech that completely changed the game. It's a story of constant improvement, of making things better, cleaner, and more powerful. So let's take a look back at where it all began and trace the path that brought us to the sophisticated AI-powered tools that developers are using right now, today in 2025. Let's rewind the clock way back to the early days of computing, like the 1950s and 60s. Back then, writing code was a physical process. There were no keyboards or screens like we have today. Instead, developers used something called a punch card. This was a stiff piece of paper, and you would write your program by punching a series of holes into it using a special machine. Each combination of holes represented a character or a command. If you made a single mistake, punched a hole in the wrong spot, you had to throw the card away and start over. It was a process that required an insane amount of patience and precision. Once you had your stack of cards, which represented your entire program, you didn't just run it on your personal computer. There were no personal computers. You would take your stack of cards to a massive, room-sized mainframe computer. A computer operator would feed your cards into a card reader, and the machine would process your program. This wasn't a quick process. You would often have to wait hours, or sometimes even a whole day, just to get your results back. And if there was an error in your code, you wouldn't find out until you got a printout with an error message. Then it was back to the drawing board to find the faulty card. This whole workflow was incredibly slow and tedious. Imagine writing an essay by punching holes in paper, handing it to someone to read, and then waiting a full day for them to tell you about a typo on page 3. That was the reality for early programmers. Collaboration was also extremely difficult. If you were working on a team, you had to physically manage these stacks of cards, making sure nobody lost or mixed up the order. It was a logistical nightmare. The tools were rudimentary because the technology itself was in its infancy. The focus was just on making the machines work at all. But even with all these challenges, this era laid the foundation for everything that came after. It forced developers to be incredibly disciplined and methodical. You had to think through your entire program from start to finish before you even touched the card punch machine, because the cost of a mistake was so high. This painstaking process taught the first generation of coders the importance of careful planning and debugging. It might seem ancient to us now, but without the struggles of the punch card era, the drive to create better, faster, and more user-friendly tools might never have been so strong. By the 1970s and 80s, things started to change in a big way. The rise of mini-computers and operating systems like Unix brought about a new way of interacting with machines. Instead of punch cards, Developers could now use a keyboard and a screen to type commands directly into a terminal. This was a huge leap forward. The interface was still just text, no fancy graphics or mouse pointers yet, but it was interactive. You could type a command and get an instant response. This feedback loop, which used to take hours, was now reduced to seconds. This era was defined by the Command Line Interface, or CLI. This is also when powerful programming languages like C became popular. C was designed to be fast and efficient, giving developers a lot of control over the computer's hardware. Alongside it, the Unix operating system came with a collection of small, specialized command line tools. There was a tool for editing text, like Vi or Emacs, a tool for compiling your code, the C compiler, CC, and tools for managing files. The philosophy was simple. Each tool should do one thing and do it really well. Developers could then chain these tools together to create complex workflows, all from the command line. For example, a developer could write their C code in a text editor like Vi. This was a bare-bones editor, purely text-based, and you had to learn a bunch of keyboard commands to do anything. There was no file. Save menu. You had to type a command like :W to write your changes to the disk. After saving the code, you'd switch back to the command line and run the compiler to turn your human-readable code into a program the machine could understand. If there were errors, the compiler would print them right there in the terminal, and you could quickly go back to the editor, fix them, and try again. This was a massive improvement in speed and efficiency. The process was still very manual, and you had to know all the right commands, but it gave developers a sense of direct control. It felt like you were having a conversation with the computer. This command line-driven workflow became the standard for a generation of programmers and is still used by many developers today. It was powerful, flexible, and once you got the hang of it, incredibly fast. This era established the core components of modern development: an editor, a compiler, and a debugger. Even if they were all separate programs you had to run manually. As computers became more powerful and graphical user interfaces with windows, icons, and mice became common, the world of software development was ready for its next big upgrade. This came in the form of the Integrated Development Environment, or IDE. The big idea behind an IDE was to take all those separate command line tools, the text editor, the compiler, the debugger, and bundle them all together into a single, cohesive application with a graphical interface. Suddenly, you didn't have to jump between different terminal windows and remember 100 different commands. Everything you needed was in one place. IDEs like Turbo Pascal, and later Microsoft's Visual Studio and JetBrains' IntelliJ IDEA completely changed the game. They introduced features that developers now take for granted. For example, syntax highlighting. This feature colors different parts of your code. Keywords in blue, strings in green, comments in gray, making it much easier to read and spot mistakes at a glance. Another killer feature was code completion. As you started typing a function or variable name, the IDE would pop up a list of suggestions. This not only saved a ton of typing, but also helped you discover parts of a programming language you might not have known about. The integration was the key. You could write your code in the editor, and then with a single click of a button, the IDE would compile it and run it for you. If there was an error, you wouldn't just get a cryptic message in a terminal. The IDE would highlight the exact line of code where the error occurred and often give you a detailed explanation of what went wrong. Debugging also became visual. You could set breakpoints in your code, which are like little stop signs. When your program reached a breakpoint, it would pause, and the IDE would show you the exact state of all your variables at that moment. This was like having X-ray vision into your program's brain. This shift to IDEs made software development much more accessible, especially for beginners. It lowered the barrier to entry because you no longer needed to be a command line wizard to get started. All the complex steps were hidden behind user-friendly buttons and menus. For professional developers, IDEs boosted productivity immensely. They could build, test, and debug applications faster than ever before. While some developers still prefer the simplicity and control of a text editor and command line tools, the IDE has become the standard for most software development today, providing a powerful and organized cockpit for building complex software. As software projects got bigger and more people started working together, a new problem popped up. How do you manage changes when a whole team is editing the same code at the same time? In the early days, honestly, It was kind of a mess. Folks would accidentally overwrite each other's work, or a shiny new feature might end up breaking something that used to work just fine. The answer was something called a version control system, or VCS for short. The basic idea is pretty simple. A VCS is just software that keeps track of every single change made to your code over time. It's kind of like having an unlimited undo button for your whole project. Early systems like CVS and Subversion, also known as SVN, were a huge leap forward. They used a central server to store the master copy of the code. Each developer would check out a copy to their own computer to work on, and when they were done, they'd commit their changes back to the server. The system kept a full history of all these commits, so you could always look back and see who changed what and when. If a bug crept in, you could easily spot exactly which change caused it and roll back to a previous working version. This was a massive improvement for collaborating as a team. It stopped developers from accidentally overwriting each other's work and gave everyone a single source of truth for the project. But, these centralized systems had a pretty big drawback. You had to be connected to the central server to commit your changes or even see the project's history. That made it tough to work offline, like if you were on a plane or a train. Plus, if the central server went down, nobody could check in their code and the whole team could get stuck. So the stage was set for a new, more flexible approach to version control. That new approach was Git. Developed by Linus Torvalds, the creator of Linux, Git is a distributed version control system. The key difference? Instead of just one central repository, every developer has a full copy of the entire project history right on their own computer. This means you can commit changes, view history, and even create new branches without needing an internet connection. You only need to connect to a shared server, like one on GitHub or GitLab, when you're ready to share your changes with everyone else. This distributed model made Git incredibly fast and flexible, and, well, it quickly became the industry standard for version control. For a long time, a developer's work was tied to a specific, powerful computer. You had your development machine, carefully set up with all your tools, compilers, and project files. If you wanted to work from a different computer, you had to go through the hassle of setting everything up all over again. But then, just as services like Google Docs and Dropbox moved our documents and files into the cloud, the same revolution came for software development. The rise of cloud computing introduced a new paradigm: cloud-based development tools that let you code, build, and deploy software from anywhere with an internet connection. One of the first big shifts was moving code repositories to the cloud. Platforms like GitHub, GitLab, and Bitbucket took the power of Git and made it accessible through a web interface. They became more than just a place to store code. They turned into collaborative hubs for software projects. Teams could not only share code, but also track bugs, manage tasks, and perform code reviews, where developers could comment on each other's changes before they were merged into the main project. This made collaboration seamless, even for teams distributed all over the world. The project's entire lifecycle lived in one central, accessible place. The next logical step was to move the entire development environment into the cloud. Services like GitHub Codespaces, Gitpod, and AWS Cloud9 emerged, offering full-featured IDEs that run entirely in your web browser. This is a game changer. It means you can open up a laptop, a tablet, or even a Chromebook, log into a website, and instantly have access to a powerful, pre-configured development environment. All the heavy lifting, like compiling code and running tests, happens on powerful servers in the cloud, not on your local machine. This untethers developers from their desks and makes it incredibly easy to get started on a new project. This cloud-based approach also solves the classic "it works on my machine" problem. Because every developer on the team can use the exact same cloud environment, it ensures consistency. You no longer have to worry about differences in operating systems or installed software causing strange bugs. The cloud also enables powerful automation through services known as CI/CD, which stands for Continuous Integration and Continuous Deployment. These cloud-based tools can automatically build, test, and even deploy your application to users every time a developer pushes a new change. This automates the release process, making it faster and more reliable than ever. The latest and arguably most disruptive evolution in software development tools is the integration of artificial intelligence. For years, AI has been getting better at understanding and generating human language, and now it's getting incredibly good at understanding and generating programming languages. This has led to a new class of tools often called AI code assistants or AI co-pilots. These aren't just fancy code completion tools, they are genuine partners that can help you write code, find bugs, and even learn new things. The most well-known example of this is GitHub Copilot, which is powered by OpenAI's models. So how does it work? As you're writing code in your editor, the AI assistant analyzes the context of what you're doing, the code you've already written, the comments you've added, and the file you're working on. Based on that context, it suggests entire lines or even whole blocks of code for you to use. For example, if you write a comment that says // function to fetch user data from the API, the AI might instantly generate the complete working function for you. You can then accept the suggestion, modify it, or ask for a different one. It feels less like a tool and more like you're pair programming with an incredibly fast and knowledgeable partner. This technology is a massive productivity booster. It can handle the boilerplate, a term for the repetitive, standard code that you have to write over and over again in many projects. This frees up developers to focus on the more complex logic and creative aspects of their work. It can also help you code in a language you're not familiar with. You can describe what you want to do in a comment, and the AI can generate the code in the correct syntax for that language, acting as a real-time translator and tutor. It's like having the entire internet's worth of coding examples right at your fingertips, ready to be adapted to your specific problem. Of course, these AI tools aren't perfect. They can sometimes generate code that is incorrect, inefficient, or has security vulnerabilities, so the developer is still very much in the driver's seat. You still need to understand what the code is doing and review it carefully. But as a tool for accelerating development and overcoming mental blocks, it's revolutionary. It represents a fundamental shift from developers just writing code to developers guiding an AI to write code. This new partnership between human creativity and artificial intelligence is reshaping what it means to be a software developer in the modern era. So, what does the toolbox of a typical software developer look like today, in 2025? It's not just one thing. It's a sophisticated combination of all the innovations we've talked about. A developer's daily workflow is a seamless blend of local and cloud-based tools powered by version control and increasingly augmented by artificial intelligence. It's a setup designed for maximum productivity, collaboration, and quality. The journey from punch cards to this point has culminated in an incredibly powerful and refined ecosystem of tools that work together in harmony. A developer will likely start their day by opening their favorite IDE, something like Visual Studio Code, or a JetBrains product like IntelliJ or PyCharm. These modern IDEs are highly customizable with extensions, so right inside their editor, they'll have their Git integration, their AI copilot, and tools for running and debugging their code. They are no longer just simple text editors. They are command centers for the entire development process. The IDE provides that core environment where the developer spends most of their time, bringing all the necessary tools into one unified interface for a smooth and uninterrupted workflow. Next, version control is the backbone of everything. Before writing any code, a developer will use Git to pull the latest changes from a cloud repository hosted on a platform like GitHub. As they work, they will commit their changes locally, creating a safe history of their progress. When they're ready to share their work, they'll push their changes to the cloud. This triggers a whole chain of automated events. A CI/CD pipeline will automatically run tests to make sure the new code doesn't break anything, and if all tests pass, it might even deploy the changes directly to a staging server or even to production users. This level of automation is standard practice now. And woven throughout this entire process is the AI assistant. It's helping them write code faster, suggesting better ways to structure a function, and even helping them write the documentation and tests for their code. The modern developer is not just a lone coder, but an orchestrator of these powerful tools. They use the IDE as their workspace, Git and GitHub for collaboration and history, cloud platforms for deployment and automation, and AI as a creative and productivity partner. This combination allows individuals and teams to build, test, and ship complex, high-quality software at a speed that would have been unimaginable just a decade or two ago. Looking back, The evolution of software development tools has been a relentless march towards making things easier, faster, and more powerful for developers. We've gone from physically punching holes in cards to having AI partners that can write code for us. Each step in this journey has abstracted away a layer of complexity, allowing developers to focus on higher-level problems. So what's next? Where does this trajectory take us? The future of coding tools is likely to be even more intelligent, collaborative, and abstract. We are probably on the cusp of another major shift in how we create software. One of the biggest trends we're likely to see is the rise of even more powerful AI-driven development. Today's AI copilots are great at suggesting code, but future tools might be able to take on much larger tasks. Imagine describing an entire application in plain English. I need a mobile app for a local coffee shop with a menu, online ordering, and a loyalty program. And having an AI generate the entire project structure, the database schema, the user interface, and the basic code for all the features. The developer's role would shift from writing line-by-line code to acting as an architect, guiding the AI, refining its output, and focusing on the unique creative aspects of the application. Another area of innovation will be in what are called low-code or no-code platforms. These tools aim to make software development accessible to people who aren't traditional programmers. They use visual drag-and-drop interfaces to let you build applications, much like building with Lego bricks. As these platforms become more powerful and integrate with AI, they could allow business experts, designers, and entrepreneurs to build sophisticated applications without writing a single line of code. This would further democratize software creation, empowering more people to bring their ideas to life. The tools will become so good that the tool itself disappears into the background. Ultimately, the goal of future tools will be to close the gap between an idea and a working piece of software as much as possible. We can imagine tools that automatically detect and fix bugs before a human even sees them, development environments that can predict what you need before you ask, and collaborative platforms that feel as immersive as working in the same room, even with a team scattered across the globe. The core job of a developer, solving problems with logic and creativity, will remain. But the tools they use will continue to evolve, becoming smarter partners that handle the tedious work, allowing human ingenuity to be applied where it matters most, in creating the next generation of incredible software. If you learned something new, like the video, share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.